Hey class, welcome to another science lesson from Mr. Huddleston. This is part 2 of our tilted Earth. What is the reason for the season? So if you haven't done part 1 yet, you need to go back and do part 1. Go ahead and do that now if you haven't. This is part 2. So if you did part 1 correctly, you should have a line graph that looks something like this that you see here. You should have a double line graph. You can see I represented Cedar in the green, moving up kind of like a hill or a mountain and then dropping down. And then Australia, Sydney, Australia, moving kind of down like a U shape, kind of like a shallow valley or U right here. And they kind of make a cool little circle in the middle there, and how they're just about almost opposites in their and during their temperatures, average temperatures throughout the seasons. And so we have the temperatures. This is in Fahrenheit, by the way. I know we usually do Celsius and metric, but I decided to do Fahrenheit because that's more familiar with us, because that's what we use at home. From 0 to about 80 degrees. And then we have the months from January through December. And we can see Cedar Woolley starting fairly cold, steadily rising up to its peak at 74, and then starting to drop a little bit through the rest of the summer. So August is the hottest month, and then down through September and to fall, and then down to December where it's cold again, obviously. And then next year would be January again, starting there. So January is our coldest month for Cedar Woolley, and August is our hottest month on average. For Sydney, Australia, January starts off in 75 degrees. And that right away, it looks like it's hottest month. Second hottest month is February, 74, 70 degrees, so on, drops down to the 60s. The coldest it gets in Sydney is 55, which looks like on average it gets a little bit colder in Cedar Woolley, which makes sense. Australia is a fairly tropical place. Pretty rare for it to get down below the 40s there. And then you see Australia, that's its lowest point is in July. So just about our middle of our summer, right? Pretty hot here in July and August, and that's kind of the coldest time. So their winter is our summer. Imagine that. Their winter, which is more of a wet season from them, June, July, August, are their coldest months. Pretty wild. Well, our summer, June, July, August, is generally our hottest time of the year. So Christmas time for them is much, much hotter. So December, 72 degrees. Well, Christmas time for us in Cedar Woolley is around 43 degrees. So those are some of the differences that you should see in two very different places of the world. Now, if you were to do this in different other cities around the world, we would see different line graphs. But pretty cool to look at. And that's some data right there to show how the different hemispheres have different weather phenomena happening at the same time. So while we're going into summer, Australia is going into the colder time of year. You might remember back during the wildfires, that was happening during our winter and during their summer. So next up, once again, reminder about the shape. The Earth is round like a ball or sphere. It's not accurate enough just to say round. You have to say like a spheroid or an oblate spheroid if you want to get really technical and really accurate. And it's kind of like an orange. It's kind of lumpy and imperfect and squished and wider in the middle. It's not a perfect sphere like a perfectly inflated soccer ball or basketball. It's a little lumpy. And the Earth rotates. It rotates on its axis every day. You can model this by turning around. It turns around every day, and so that's day and night. So the Earth is spinning, it is rotating. So right now, as you're going from morning to afternoon to night, that is during the rotation. And you're rotated the opposite way during nighttime. That's why it's dark. The sun is not shining on that part of the Earth that you're in. And while it's rotating, it's also orbiting. So the Earth is rotating and spinning while it's orbiting around the sun. The Earth moves around the sun in an orbit. The Earth orbits or revolves around the sun one time each year. That's how we measure a year. About 365 days is one successful orbit around the sun. Obviously, in this model, the sun is not to scale. It's just showing you that the sun would be in the middle, And remember, we got to know that the Earth revolves around the sun, not the sun revolving around the Earth. And you can see that tilt there for the different weathers. So right here, Earth's orbit with the equator there, where it's summer, and the northern part is pointed towards the sun as it changes into fall, and then winter, the northern hemisphere is pointed away. So it's summertime in Australia and winter in North America, and then spring. So I posted several videos to explain this tilted axis and the orbit around. So you're going to use those use those videos to add to your evidence. So this axial tilt, this is the important part for our tilted Earths to know. This is actually about how many degrees it's tilted, about 23.5. The Earth is tilted on its axis. Notice how the northern hemisphere receives more sunlight during the summer. Look at the North Pole. And a hemisphere is half a sphere. If you were to cut the Earth, or like an orange or a tomato or something, in half, that's a hemisphere. So we have a northern hemisphere that's from the equator up, a southern hemisphere, eastern, and a western hemisphere. We're in the northern and western hemisphere. So this is right around where we are, in North America. And you see how the northern hemisphere is pointed? Now this would be spinning, right? So, for example, England and Ireland and Japan and northern parts of Asia also have the same seasons as us. It's mostly different from north and south because of that tilt. So in this case, the northern hemisphere is pointed and receiving more sunlight than the southern hemisphere. And then during our winter, the Earth's tilt is going away. Once again, the videos will do such a good job at showing you this visually. So if it's still not making sense to you, don't panic. Watch the other videos I've posted for you, and you'll add that to your claim that you're going to make. So here's a cool little animation I added here. It's going very, very fast, but it's showing the moon orbiting the Earth as the Earth is spinning. It's almost making me dizzy, and orbiting the sun. And you see this imaginary kind of straw through the Earth is representing its axis, as that tilt stays. So we've got, you can see the sunlight there. It's going very, very fast. So what you're going to do today, you're going to write a claim with evidence. So this will be a couple sentences or so, and this is here to help you frame it. Now let's pull all our evidence together with some reasoning to write down our claim. You can use your evidence from the data we made yesterday. So here's what you need to answer. Does the Earth really get closer to the sun in the summer? Okay, does the Earth really get closer to the sun in the summer? No, but you need to say why. How do you know it doesn't get closer to the sun? If you had a younger sibling asking you, like, oh, is it summer because we're closer to the sun? What is our evidence for the tilted axis? How do we know that the Earth is tilted? So you guys already have evidence. You have the data you put in a line graph. You can show that in Australia during our winter, during Christmas time, it's very hot there. Well, it's pretty cold in another place like Sijuwuli. And the opposite is true during their winter and our summer. Write like you were explaining to someone else. So I always say this, write like you're explaining to someone else. Never assume that they know anything. You have to write it very, very specifically. All right. So you'll also be gathering more evidence in those videos. It's up to you on how you do that. You can write down a couple sentences as you pause it and keep going through it. You can write some dash facts down on paper as you go, and then add that to your final claim. So once again, does the Earth really get closer to the sun in the summer? What is our evidence for the tilted axis? So how can we tell that the Earth is tilted? Because if it wasn't, we would all have the same seasons all the time. In fact, we wouldn't have seasons. We would just have the same weather. Interesting. That's why countries that are closer to the equator, like in South America and parts of Asia and parts of Africa, their weather usually stays very consistent through most of the year because they're not affected by that tilt as much. And write like you're explaining to somebody else. Usually, this is where in class I would be having you bring up a globe. I would be showing us in class with a flashlight just how the sunlight coming to the Earth really makes a difference on how the Earth's tilted. Obviously, we don't have that, so that's why I've posted a couple videos for you guys to watch. Have fun, good luck, work hard, and I'll talk to you guys later.